chip that we use for it, the BMD200 made by Rigato. I helped design this with my coworker Michael Peterson. So I'm Rushan, or Andrew, and we're going just through the basics of how to get it out on GitHub at the DC801 GitHub. There's a DC801 DC24 party badge link folder that has all the hardware and the software for the badge. So it has all the schematics, Gerber files, everything, silk screens that we use. It's all done in Eagle with EagleCAD, so you can go mess around with that and look at it all you want. Has all the chips. We have the bill of materials, the BOM, in there as well, listing all our parts that we use. So the badge has 2 RGBs at the eyes. There's a button that's labeled SLC, and then there is 5 sets of 2 orange LEDs around the perimeter of the badge. And then the bleed module, we have it set up as an Eddystone beacon by default, so it broadcasts a URL. So on your smartphone, certain smartphones, some of the newer ones will auto sense the website and will give you a notification at the top. But then we'll redirect you. You click on it, it'll take you to the website that the badge is broadcasting. Or you might have to download a beacon reader off of the Play Store or the Apple Store, whichever one. Nordic has some nice tools too. They have Nordic's tools that you can download for your smartphone as well that will help you do development with the BLE. It has different programs within it. So all the other things, because you can have proximity with your BLE device, you can do the Eddystone or iBeacon. You can also do you can also make it act like a mouse or act like a keyboard. There's lots of different things you can do with the BLE. And the tools that I'll go through will kind of help you do it. There's a lot of example code for it that you can play with. We have a few dev boards. So the dev board for the BMD200. That better? Zoom in. Okay. And then this one has a built-in Sager programmer for it, and it has all the breakouts for the GPIOs here, and it will broadcast, and has a ceramic antenna, and it runs on a Cortex M0 processor. So there are some tools that you'll need to do it. There's NFR Go Studio, which will get you this program right here.
You want to show us the link and everything?
The link?
Yeah, like go download it, show us where to download it.
Does this have the internet?
I don't know, it might need to be set up. It should have wireless.
Kill. Yes.
Put this on the meetup link.
So for these BLE modules,
What's the link?
by default,
Just do a search for.
it's pretty good to do this. Kill. If you go to kill.com/download/product
There you go.
/ and then there's the MDK ARM. And this is the one that you want to download right here, whatever the newest version is. So you'll need that tool. This has some limitations for the free version. It'll let you do about 32K of code, and you have to print in some information to download it. So you want to get through that. And then the other tool to download is this NordicSemi.com, not Chinese. And get the NFR Go Studio.
The starter kit or the SDK?
For the
Go Studio?
Go Studio should be the starter kit, I believe. Should be an NRF Go Studio _ Windows 64-bit. Trying to figure out where. That was.
Yeah, mine defaulted different language too.
So they have a 32-bit or a 64-bit version. I guess it's 1.21.2 for NFR Go Studio. So download to your appropriate version, most likely 64-bit. Once you get those installed, NFR Go Studio will show up. And then for the badge, you'll need a Seger or a SWD programmer to work with it. That has a 10-pin adapter if it doesn't automatically go to the 10-pin. And installing those tools will download the drivers for the Seger as well.
I'm gonna leave this here so people can use
It's
it.
gonna be hours to download.
Okay.
So we'll be ready by tomorrow.
So once it goes in, the programmer will go in. You have your badge. On the back, we have the nice connector for it. You plug it in. That's off. And then NFR Go Studio should find it. This one has recovery. I don't want to really cover mine right now. But it'll come up, and this is where you put your soft device. The soft device will be an S1.
Well, what's a soft device?
Soft device determines on the functionality of what your bleed device will be able to do. So within that GitHub, we include the S130 NRF51 version 1 soft device hex. This right here will let you become a central and a peripheral device at the same time. We don't have a central made for our chip right now, but a central will let you connect other peripherals to it and then broadcast it through so you can do mesh networking. That will be a possibility with the bleeds, especially the newer bleeds that do Bluetooth 4.2. They're made more for the Internet of Things that we're looking at. But these are Bluetooth 4.1 devices right now. And there's a whole bunch of different things. So a central peripheral will let you run both types of programs through it. That's why the S130 is the ideal. They have an S110 and S120. S110 is strictly more peripheral device, and S120 is a little bit more of a central type application. So we're doing the S130 to give it the most functionality straight up. It'll go through, and that's basically your firmware for your bleed device. So when you program them.
So is that the soft device is the code, or is it the bootloader?
It's your bootloader.
Oh, okay.
It
So
goes through and defines what your chip is able to do.
Mm-hmm.
So when you get into your code,
That's the soft device. So what do they call the other one? The hard device, or?
I haven't heard of hard device. Soft device is all that is really done in it.
Oh, okay. Well, I remember you told me there was two files, right? There's the soft device, and then there's the hex. It's the actual
Code.
program. The code.
Yeah.
Yeah.
So that's the application, I
The
guess.
application.
So
So
this
there's-
is like your firmware and then your application that runs on top. So your bootloader, kind of your OS
Mhm.
per se, is your soft device, determines your functionality. Then your application utilizes that firmware to run its application.
So it's kind of like an operating system.
Yeah. Briefly. This one has. Is this our new code or is this the old code? This is the older code. I can open it up. I know this should be. I guess this is the new code. Right here. So within Kill, this is our C. It has all the predetermined H files and all the supporting files for the application. When you first install it, it'll let you go through and let's see, where is that? This one, our program has everything predefined for you for the flash. So for configuring, so initially you'd have to configure your flashing for the badge. So you'd have your target, which is your locations in memory, right there, which are defined by the type of soft device that you're using, and then the leftover RAM that you're able to use. There, and then you go into the C++. This is where you do your custom H file. So we have a board._custom, which is defined by the thing. So the dev board actually has a different custom H file that you can download straight from Regato when you play with the dev board, and it might be in the software downloads as an old board custom.h there. And then you have to, that H file goes at this location that you have to make sure you add to the include path right here. And that gets it so it can notice what type of board you have, how you have your board configured. So that determines your GPIOs.
So it determines what chipset you're using.
Basically, yeah.
And so the target device, that's just the configuration of the soft device you were saying.
What your bleed soft device is determines this IROM right here.
Mm-hmm. So whatever soft device you get and so where did you get the soft device?
The soft device comes from Nordic,
Mm-hmm.
and then Regato has some info on if you're using this soft device, then you should use these parameters.
Oh, okay.
Some of it was trial and error. They have a newer soft device with the 130 that's of like version 2
Mm-hmm.
that worked on the dev board, but didn't work on our, because it's not a production ready soft device. So we tried on our board and it didn't work. So we had to go back to 1, which changed our values from our dev prototype program to the real program.
Mm-hmm.
So we had to play with the ROM values
Okay.
to get those right. And then the linker, debug. And debug, you use the JLink, JTrace, Cortex. As long as that's set up, those are your three big things that you have to set up. The code that you get automatically is pre-set up for the DC801 badge, so it's all pre-configured for it. That's the nice thing with because we put the whole project there, the project keeps its settings, so you don't have to go in. But if you do mess up your settings, those will be the three things that you have to look at, make sure they aren't changed in order to finally program your board. So the first thing that you do is with that NRFR Go Studio is that you flash it. You erase it and then you reflash it. But once you have it done with the soft device the first time, then you don't have to do that anymore on initial go through. Or if you mess with your program and you can't brick your device, this is the way that you can recover it. Because this will go through and wipe your whole memory. The application, the soft device, it will erase it all. So you can start from scratch. And then this tool will also let you program the application through it too. So if you have the hex file for the board, then you don't have to have the killed environment. You can download the hex straight through here. So
Is it pretty easy to soft break it at all, or is it?
yeah, I've break the dev boards multiple times.
Nice.
And it's really easy to recover. The new NFR Go's are much better because they used to not have this recovery that was easy. You just go, do you want to recover? And you just hit yes until it finally did. Now it actually will recover like the first time.
Very cool.
So at least they do update their software pretty rapidly. Over a 3-month period, they've done multiple updates and they fixed some bugs and issues. So heavily used. Marv, should I see your board? I can program it. Alright. So you have the whole code.
So mine, the RF5X programming is disabled. Do I have to have that thing plugged in?
No, don't do motherboards. It's the development boards. So it actually sees it.
I make a CD.
That's the thing.
Yeah. So on the NFR Go, you need to make sure that you're on this NRF5X programming right there. If you're on any of the other ones, it won't show right.
I see.
You want to be there. So let me just reset this one.
It looked like in the background you had an IDE of sorts opened up.
The IDE is the kill.
Oh, that's right.
Oh, it's dead.
Sorry.
I don't know, the last couple of days.
Yeah, recovery bells every so often.
No. No, thanks.
Are you sure?
Yeah, I'm pretty sure.
It's just a random QR code that someone at that point gave me.
Yeah, sure.
Who could possibly go wrong?
Yeah.
Let's just trust that.
So you have to have the board on.
Don't do it.
So the board's on.
You can't know how to fix something until you break it. Right?
You get the app. It shows up like this.
Hold on.
So you erase all.
QR code generation.
Just wipe the whole thing. Then you go to Program Soft Device tab. You browse to where you have the hex for the soft device. Click Open, and you click Program.
You killed my badge.
Takes a little bit. So this program, so now you have a region 0 with your soft device. So that sets up, and it takes up 112 kilobytes. And it also has an ID number and it has that address, the 1C00, that should correlate to the address in your programmer in here. Under the, no, where was that? Target, yeah. Which deals with your IROM.
Mm-hmm.
So this is basically where you start and how big it is. We have 256 kilobytes of memory to play with on this device, which is kind of cool. And straight from kill, once you have it programmed and set up, you just load, and it will load straight to the badge. And it programs it basically instantaneously. And you can debug through it, and you can program it in real time with this. And literally F5, recompile, and then reload, and it instantaneously overwrites the application layer. So you never have to go back and do the hex anymore. But within this, there is a way that you can go in, and if you have the hex file for the program, and if you don't have, so if you have this other people's hex files, you can go in and just grab the hex program from kill or your development and load it straight through the NFR Go Studio as well. And then you can program it straight from that application as well. And it'll program your badge. So that's your basic environments and how to program it and how to initiate it as a soft device. The dev boards, the soft device setup is the same. The programming would be a little bit different because you need a different H file for that board. So the big thing within the programming is if you tweak the badge or reconfigure it differently, you need to go through and change that custom.
That was in the linker, right?
Yeah, that's in the,
So in the linker, what is the custom
not
board?
the linker, the C++.
Oh,
C++.
okay.
It's board_custom.
What does that refer to?
It is basically your, shows your pins and all the devices.
Well, like, is it pointing to a file, or is it, what does it mean?
Yeah, it's pointing to the .h file
What
for the
.h
board.
file?
Custom, I'm gonna pull that out.
So do you you have a .h file that is named custom,
Yeah, board_custom.
and so does that tell the compiler to use that file?
Yes, it tells the compiler to use that file so it can program to your device that you
Okay,
have.
so there's the custom board.h and then on the bottom there.
There we go.
So that's the file that you're defining in
Yeah.
the C++ area.
Yep.
And this is all of the BLE information on all of the pins and everything, right?
Yeah, this is how you configure your pins.
Mhm.
So with us, you can, for our dev board, for our party badge, you can tell it has the red. So the pin that governs the red LED on one of the eyes is pin 0, and then the green and then the blue for the RGB set is 0, 1, and 2. And then on the next RGB, it's pins 3, 6, and 10. So it's basically telling you what signals go where for your program. So when you call out, I want this LED or this device to turn on, this is the file that determines what pin gets that signal.
Mhm.
So it's your guide to your
Okay.
program. So all this has all the pinouts for what's on the badge. We do have 3 pins that you can play with on the party badge that are off on the looking at on the right hand side. That is a full I2C bus. Right over here, that's a full I2C bus and an extra pin for clocking or other things that you want to do with it. So they're full GPIOs that you can solder and connect to and add them into the H file.
So did you write this H file, or was this like one that was generated for this board and you modified it?
I took the dev board H file and customized it for our badge.
Oh,
So
okay.
I basically wrote the H file.
Mm-hmm.
Then we went through and updated the H file to make it easier to program different LEDs in code. So that's the orange LEDs and specifying the orange ones, all the right ones, all the left ones.
Mm-hmm.
So it takes less code in the main to then program and to light those up.
Where's the entry point for the code?
So the big part is right here, is that we have a switch function, a case statement for the light, for the
Eyes.
RGBs, for the eyes.
Well, where's the main function? The one that
The
like
main
the entry
is
point?
all the way down here at the bottom.
Yeah, it's like a convention, so main's always at the bottom because all the
Yeah.
defines are up above it.
All the
this.
defines are far. So this goes through, it basically calls power manage, and
Mhm.
power manage is all our LED functionality. Because that goes into the broadcast of the Eddystone with this one.
So you have to maintain a loop.
So it's a loop that goes through.
Okay, yeah. So it's different from Arduino because they have the loop.
Yeah.
But so in this you have to maintain your own loop, otherwise the program will exit.
Yeah. So it goes into power manage here.
Mm-hmm.
And then you turn off all your LEDs and then turn them on and do things. This actually looks like the older code. So I might need Hamster to update it. So this will go through, but we made the eyes really easy to program now. So you just type in the color that you want. Or else it would have been like 5 or 6 lines of code to do eye changes. So we made it into the case statement. So all you do is just tell it the color that you want, choose your loop timing, how many milliseconds you want to go into, and different patterns are just different loops as it goes through. Then the button will actually pull and switch. So I believe Hamster has it so the button will jump into different programs depending on how the button is pulled.
In other news, there's a button on the badge.
Yes. Which I guess Marv never got the notification that there was a button on the badge. And then up here, this is where you play with the broadcast of the Eddystone. So right here, this hex value right there is what it's broadcasting. So you have to put in hex code, and it will broadcast a web address for you. So you can play around. Ideally, you want to go put it into like Google shortener.
Why don't you just show us?
So what is that?
To change it to DC801, just the site or something.
Wait, what was the Google shortener? Is it Google.l? Google.le?
Yeah, just type Google URL shortener, it'll take you
Oh, there we go.
there. U.gl.
Google.gl. And then there's ASCII to hex website. That's very useful. So if you want to go through and go to DC801.org, goes through that and it gives you your hexadecimal value. And then you just take that, copy and paste it into here, and that should be the first little bit of this one. There's value right above it. A 03 equals an HTTPS : // and then 01 is a HTTPS / www dot. So anything before your main address you want to play, and on GitHub there's a whole Google Eddystone GitHub that talks all about how to set up Eddystones. Oh, here's a good one. There's a lot of Eddystone information out there. You can set up official beacons, but there we go. That's what I wanted. On GitHub, there's Eddystone, and then Eddystone URL, and this will go through. So 00 is HTTP, www.01 HTTPS, www.02 HTTP, 03 HTTPS. So you don't have to do any of that in your hex. It auto does it with the upper value. And then for different endings, they do have special codes to go with it as well. If you want to do it with the ending. If you do a Google shortener, then all you do is get that first part, HTTPS / or whatever that you need for your address. Put in the Google shortener. And since Google shortener puts its own URL to it, so it's really, instead of putting this into the hex, you take this, throw it in the Google shortener, whatever one you want, which gives you that. So it shortens, you take that, you plug it in here, you convert that to hex. And then you take that hex code and copy this into here, add your commas and add the 0x in front of each of the hex parts. And this replace that set. This way you don't have to deal with really long URLs. And you won't have to have a huge amount of hexes to mess
Is there a
with.
maximum length?
I'm not 100% sure. I think there is a max length that you can do. I think it's around, I want to say 10 to 20-ish.
Mm-hmm.
Because this one's about 12.
So does it always have to be hard-coded, or could you update it dynamically?
This is hard-coded for this. There is ways. Rigato does have some tools to set up apps for your smartphone. They'll interface that you might be able to dynamically change it through the app that you can program for your Blee device. So yeah, these Blees will communicate with custom apps that you can program on your smart devices as well. So any of the Android, that gets into the Rigato. Rigato has a little suite. And then the Nordic, where's my Nordic? So if you go to the Nordic Semi, there's an NRF toolbox that you can get for your smartphone. And that will go through. So we're doing beacons. So you can click on beacon. I have 0 beacons. Oh, not beacon. It's NRF Connect is the big one. So it's going through, and it shows the broadcasting devices that are there. And then within that, there we go. Okay, so this top one is the physical web beacon, which is the DC801 party badge. What it does, when you pull it up, you can actually go to more and show how often it's broadcasting and other aspects. So it's a pretty good developed environment to play with when it's your beacon, so you can make sure it's broadcasting appropriately. Also shows the URL. You can see the Google shortened URL there. And then on this screen you can click open. and then it will take you to the website so you can verify that it works. So it takes you to the 801 Labs events website. So that's all through the BLE device broadcasting and showing you what it's going. So you can have museums and other places are getting into these, so when you walk around you can download a custom app for their place. Then all the pieces of art will have their own BLE. You just connect to it and it will send you and get you more information or update their app to where you are. So that all deals with BLE applications. It's a newer thing in some of the Internet of Things applications that we can play with. So that's some of the things that you can start playing with your BLE device. And then I forget where that was. When you set up Kill the first time, it asks you to download a whole bunch of, it has a whole bunch of example programs.
No, you can show us.
That's what I'm trying to remember where it is. Flash projects. Now I can't remember how to get there. Package installer. There we go. Okay, so I have a whole bunch of packs in here.
And what are these?
These are example codes that you can have. So we have an NRF 51422 AC. Then over here,
That's the chipset?
that's a chipset that we're based off of. And then all these Nordics pop up. And then you come over here and you install the ones that you want. Over here.
So the ones that you installed, what do they do?
They give you your drivers or some of these different BLE, a lot of your components. And then right here, your S130 soft devices. That gets you more of the drivers and base program tools that you need to do your program. So all the helping files for BLE, stack, GAT, all these extra folders here that have the key on them,
Mm-hmm.
which don't count towards your kill code base. That's why you can play with this a little bit for smaller programs, but then if you want to do bigger ones, then you either have to buy the full kill or move over to GCC and do the GCC programming.
Mm-hmm.
And all the libraries and things of this port over what you need. So this is good to have as a base to start with, but if you want to do more hardcore development, then you need to move into the GCC environment or the Eclipse, the full C++ range of
Mhm.
programming tools, so you can compile and utilize the full memory of the device. But this gives you good examples and good code that you can then reference. So these have a lot of H files and stacks and info. And on Nordic's website, they have a lot of info. On the info center, technical documents. So this NRF 51 series, you can go in here, you can choose the 51422, reference layouts, product specification. You can get into the soft devices, the S130. and goes into the API and the specification
Mhm.
for the soft device. So the protocol stack. So if you really want to learn everything in the depth on it, Nordic has really good documentation. It's all out on their website. You can dig
Nice.
into it.
Do
You
you
can
think
learn
they
about
have-
the scheduling and everything else that you need to, power profiles, data, memory usage, all on how it works.
So if you wanted to use GCC, do they have a guide on that, or?
There is a guide. Hamster knows more than me right now on that.
Oh, okay. I'll
I'm-
bug him about
I haven't been able to get with him because he's going to help me get my GCC up.
Mm-hmm.
But there is some nice things. But this also talks all on the APIs that are used for your soft device.
Cool.
And
What
then
was the model number of that again, Scott?
it's a 51422 or the 51822. I guess will also work.
Oh,
It's the 51s is what this one is.
I see.
The 52 is the newer chip.
That's gonna be.
That's a BMD 300
Mm,
that we'll be looking at.
Toga badge.
Yes. we will look at different things, but I really like Lee, and I'm planning to stay on this platform for the badges that I work on. And we'll get a simple programmer to go with it that's more universal. And then this way they'll be able to communicate and get different stacks going, because the 51s can talk to the 52s. The 52s just add more functionality. They get into some of the mesh networking. And then on GitHub, there's some more Nordic stuff. If you get into that, there's a lot of Nordic communities that are out there that are working on these, because people really like playing with them. Even just a simple module with a simple 232 battery. So your watch battery can last almost 7 days with that little battery, so you can just have that little device, this simple device, and program it and throw it somewhere and have it broadcast.
Does it run on 3 volts?
Yes, it runs on 3 volts.
Okay.
Well, 3.3 is what we're running on, but yeah, it has a pretty good tolerance of voltage, and it has a sleep mode that uses in the micro amps,
Oh, that's cool.
so it has a really good sleep mode with it.
So you can program a routine that would run during the
So yeah,
sleep mode?
so it can sleep if there's no devices around. You could probably configure it so it doesn't waste its energy when there's nothing around. And then when another Bluetooth device gets close to it or whatnot, it can wake up. They have example applications. There's that for down here. They have example applications like up in this 52. So solar powered beacons. They have their own little development thing. But in the 51s, there's reference manual, there's development. They also have code, explaining the code in here. There we go, application programming. Events, air handling, memory usage, scheduling. Pretty much everything that you want to learn about the soft devices is out on this website for you to go through.
Earlier you mentioned there's software that you use to set up the layout of the board or the
Yeah, that's an Eagle.
Eagle.
Yeah, so
That'd be another cool topic to have. Just how to use that stuff to set up something. EagleCAD.
yeah. So if you have a .edu, they actually have it free for a pretty decent version right now. So if you're a student, take it up, because they just changed their pricing structure recently. So their free one's actually pretty nice now.
Mhm.
If you have a .edu. So definitely go up and look at that. My coworker that did it, he did all the CAD layout for the badge. So he's the one that did all the traces and everything else, and I helped do the pattern. I helped determine where things were, but he did a lot of the actual tracing and making the parts in the libraries, making sure everything's there.
Nice.
Regato actually has the BMD part as a library that you can download straight into it, so you don't have to make a footprint for it. It has a keep out area too, because the antenna propagates, so you can't have any traces or ground plane in that area. So on our badge, if you look, there's a box that's kind of hard to see on the badge in the Utah. That is actually a keep out zone for propagation, so there is no circuit or ground plane through there. Everything's routed around it. So that's this PCB
I see.
right there. But you can move it so it's on the edge of the board so it doesn't fill up areas as well. But their footprint that you download will go straight into the tool. There's a free version if you don't have a .edu that's limited on size, but so for small projects it's great to learn on. It's a pretty decent program to go for a free version. KiCad is another free one if you want to play with that. That gives you more functionality and is for free, but it's a little nitpicky on how to go through. And we can probably do a PCB layout class sometime in the future
That'd be badass.
to go through that. But then there's the gold standard, which is usually like Altium. That's like a $10,000 PCB layout software. That's really, really nice. That does really good tracing and auto replacement and has a lot of rules. So there's different levels on how well you want to get into it, but Eagle's a pretty good one that a lot of people start with, and KiCad is another one that people are doing. So a lot of the badges that makers made were done in Eagle or KiCad. There was one that was done in Altium because he works with Altium and has that software available to him. But all the rest were basically in Eagle and KiCad. So we have all the files on the hardware part folder. We have the Gerber files, we have the schematic right here. So the access badge version 1.0.sch, that's the schematic for the board. So when you pull that up into your Eagle, with Eagle, you can see all the parts and how the circuits are laid out. So it's not how it's represented on it, because that's in the PCB layout part. It's all the functional circuitry. So that shows this pin goes to this thing. So if you want to verify for the H file that you're connecting your pins to the right port on your right GPO pin on your device, you verify in your schematic. This way, when you print it, you know that this goes there. If you have issues on your schematic, then you have issues with your program. So it's a good way to validate your program, make sure that you're really calling what you thought you were. Because if it's not lining up how you thought, then you're either calling the wrong pin, you have to verify in your schematic, or you missed your H file, and your H file is listing the wrong thing. So that's where your H file correlates. So when I made the H file for our board, I had to make sure, I looked at the schematic and verified that these pins were running these LEDs. So when we programmed it, what we did in program actually showed right on our badge. So all the lights that lit up were right. You get the right sequences.
Cool.
So it goes through that. Any questions? It's probably a lot to take in a short time. But that's basically how to set up the dev environment, how to get up, and now you can basically play and deal with it and have fun. Really easy to program, fast programming, and it's just simple code that you can go through.
And it runs a lot faster than the Arduino or
Yeah.
whatnot.
Since it's a full ARM and everything else, I wanted to make sure that it had good battery life and that it was really easy to program. So I'm not much of a
And then put a
programmer.
giant battery on it anyway.
The other pet peeve I had with badges is that they always died prematurely. You had to keep charging them every like 4 hours. I wanted a badge that could last all of DEF CON without having to be charged, and I think I succeeded.
Yep.
Pretty good.
Everyone was happy with it. It lit up well, and the power usage was really great.
You could hook some piezo speakers up to your feet so it recharges as you walk around the convention.
Yeah, our badge, so the USB on the badge is only for charging. It has a red LED that will turn on when it's charging, and it will turn off when it's fully charged.
Oh, okay.
And other than that,
That's done in the charging circuit, not in software.
yeah, this is all charging circuit. And the charging circuit will also, so if you unplug your battery, it will run off of the micro USB somewhat. So it will down convert. So the battery runs at 3.7, and the battery voltage goes straight to the RGB, not to the orange LEDs, to the LEDs straight, while it down converts to 3.3 for the Regato chip.
Oh, wow.
So we have a down converter in there too. So all that circuitry's there, and it's actually pretty. On the schematic, we have it broken off, so you can actually steal that circuit and use it in other programs because of how it is. So we'll go through the schematic some other time.
So how, is it pretty expensive to ship out the schematics and have it built for you, or how much, if you were to build a project?
You're looking probably around $2,000.
Okay, for how many units?
Well, how
That's
many?
the base price?
It depends on your parts and how many you manufacture. I think the minimum is like 30, right? You have to make.
5.
Oh yeah, it was
5. I mean, prototype runs are expensive. So 5. As you make more, it gets cheaper. But your prototype is your non-recurring engineering, so that's a big part of your fee to make them. To make sure that your circuit works, everything works, all your parts work, your schematic really works, your program works with your badge. So that's why we did the short run of badges, also to make sure it looks the way that you want it to. As you specify orange and you get like gray on a black PCB. So it's a good way to go through, but that's your expensive run. And then you run with the mass where your part prices go down because you're ordering in bulk. So once you get bulk processing, it gets cheaper. But
I talked to someone that did like, I think like 20 for like $800 somehow, but like I said, it really depends on your design and your size of your board and who's manufacturing.
yeah, if
it
you go in
and when
China,
you need
it's
it.
cheaper,
Yeah.
but it doesn't guarantee that they'll work. There's people that order from China and only like half their boards work, and they have to go through and
Well,
fix
and
them.
they'll do things where they'll get a part that is exactly the same, but the controlling chip is completely different, and they look exactly the same. So you coded for one chip, and then this other chip, some off-brand market chip that
Gotcha.
no one knows how it works or what it does.
That can get pretty hairy.
Yeah.
So that can mess you up big time too.
And the smaller the chips, the more expensive they go. So this is really high quality parts on this one, and we did it in country. So this is all US based, which rose the price a little bit. But we got all the badges, 250 that we made, all worked.
Yeah.
We had 100% working rate.
Yeah, that's nice.
So it was way nice. All quality controlled.
Yeah.
And it was so much easier to work with them. If they had questions on your schematic on how parts part, they asked us questions. We reoriented the part, how it's supposed to be. If it wasn't clear to them, we verified it. Like they had a question on the programmer on which way it was supposed to be, because it has a little slot on it to how the programmer fits in. So it's one way only. So if you have it backwards, it wouldn't program. It would probably fry your chip.
Yeah.
So they verified which way it was supposed to go on. The RGBs, they verified the RGBs. And around the eyes, you can't see them hardly. There's resistors around the RGBs that are 0201s. They're tiny.
Yeah.
But it printed nice, so it made a really nice, clean looking badge. That was
Sweet.
showed what it was supposed to. Well,
All right. Thank you.
Thank you.
oh,